the crowd appreciates actually will get that, will be the winner of that contest. So please be here in the feedback session.
Okay, before we start off, a couple of things. As he mentioned, this session is about basics of big data. So you're all free to ask questions in between, or as you mentioned, 10 minutes at the end, we will have the Q&A session. So we can go ahead with that. But just bear with me because I'm a first timer here. So if there is any kind of expectation that is already set from your end, please bear with me, because as I mentioned, there might be a few hiccups here and there. I have a couple of slides, so I wanted to share it along with you. Maybe we'll give, now it's in my watch, it's 9:58, so 2 more minutes and we can start off. Okay? Maybe you can tweet about the Barcamp Bangalore till then. You're free to do that. So 2 minutes and we can start off. Okay? Thank you. Okay, I tweeted a couple of things meanwhile. So can we start off then? It's fine. Okay, so big data, you would have heard a lot about it. So what is this session about is just to tell you all what is big data, and is it really so big that is what we are all hearing, or is it something that every individual can really make use of it, can relate it with big data, or how is it? Okay, so what we'll do is I have around 15 to 16 slides, I suppose. So we'll go ahead with that. So meanwhile, if any questions, feel free, because this is an unconference, so feel free to ask in questions in between. Or if you want to make sure that, okay, we'll wait till the end if the questions are already answered, and then I'll ask it at the end. Feel free to do that as well. But just one note, I'm Satish, and though I'm talking about big data, I'm not actually working on that. I am in the process of learning about big data, trying to see what are the applications and everything from my end as well. So if there are any questions, at the end, what we'll do is, maybe I'll share with you all the mail ID and how we can interact going forward. So we can discuss about that online like later. Okay? So let's start off. So what is big data? So as you see the elephant is a nice image to put it up. So that is why I put there. But the second one, if you see, that image precisely defines what is big data. Okay? Because that is how big data will look like at the end of the day. If you see the definition, I think you can see in any wiki page, but I won't talk about that too much. But what I want to talk to you is, it's a collection of data set so large and complex. Okay? It is huge, it is very complicated, because of which it becomes difficult to process using the regular database management, whatever we have right now in hand. Okay? And that is why the traditional data processing applications can't be used for processing this big data. Okay, so the questions now will be, okay, what consists of together, like makes it big data, right? What all put together will make it a big data. So we'll look at that. Okay, before we see that, this is a general trivia. So if you see, in 60 seconds, I took 120 seconds. But meanwhile, if you see what are all happening, say the tweets that you see here, 98,000 plus tweets happen in 60 seconds. So that much of data. See, 320 plus new Twitter accounts are created in every 60 seconds. This is not only the Twitter. If you see about the Flickr, 6,000 plus photos are uploaded. And Facebook, if you see what are the number of posts that are uploaded there, and 600 plus new videos will be hosted on YouTube. And the same time, blog posts, if you see, 1,500 plus blog posts will be made. And the query searches, it's huge. See the number of query searches, around 700,000 query searches will be made. So what is the data? What is the amount of data that is being generated every 1 minute? This is general trivia, okay? So that we can just imagine what is the huge amount of data that is actually being generated every 1 minute. All these are forms of data. Video, audio, images, text, database, search, everything. Everything is different forms of data. All this put together is what is your big data. Okay? So what we'll do is, in the next slide, okay, so this is the 4 V's. Okay? Until now it was called as 3 V's, and recently it has been upgraded to the next version, that is 4 V's. So this is what the slide will explain, what the data will contain. 4 V's, first one is volume. The second one is velocity. Third one is variety. And fourth one is veracity. Okay? So these are the, I can say, characteristics of the data. Okay? So volume. What is the huge volume of data that is being generated? You already saw a general trivia about it, right? So that is the volume. What is the velocity that is being generated? The data is being generated. In every minute, the number of posts, the number of tweets, the number of images being uploaded, the number of videos being uploaded, the number of documents that are being created, that is what is velocity. Variety. Now, I already mentioned, right? Images, photos, videos, posts, docs, everything. That is the variety. Veracity, uncertainty of data. We don't know, like, how is it going to change? Today, it is in a, say, some format today that can be moved to a different format altogether tomorrow. Say, I have a BMP image right now, I'll convert it into PNG. Or say BMP, everything put together, say some 100 BMC put together, I can make a video out of it. So, uncertainty of data. So, these are the 4 key factors of big data. Okay? So, characteristics, I have mentioned it as characteristics because this is where you will come to know in the data, the characteristics of data. Okay? See the pyramid structure that you see here, right? So if you see at the bottom, unstructured data. Unstructured data forms the biggest chunk in the data set. Okay? So what is unstructured data? It is the kinds of data that qualifies under unstructured data are text documents, PDFs, images, video. There is no proper structure to it, right? If anyone is like not getting this at any point of time, please feel free to ask any questions, no problem. Okay, you're getting this hopefully. So unstructured data is all these kinds of data. Okay, let's go to quasi-structured. This is a bit interesting one. Someone asked me day before yesterday how exactly this is used. So I would want to spend maybe 1 minute more on quasi-structured data. So you type in Google, say for example, some keyword, okay? And then a list of searches drop down. From there, you go to a website, okay? In that website, you find a link of some other website, okay? Say this is website A, and the website B link is available in that website A. When you click on that, you're redirected to website B, but what happens is the whole URL, the whole link, whatever is there, that's a totally different URL, okay? Because it says you have visited website B through website A. That is why, for example, you can assume it will be HTTP, URL would be website a.com/blah and website B, okay? Then, say you have visited, say, some website X or Y, okay? From there, you have again visited website B. There, the different URL is formed, okay? It will be website X -- web, blah, 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 whatever the extra strings are added there, and then it says added website B. So now, how is this utilized? So, say now website B wants to advertise their site in, say, 100 sites. Now, if the website click to B from website A is 10 times, and website X is 50 times, they'll obviously do the advertising on website X rather than website A. That is because they're getting huge number of hits through the website X. This is why it is called quasi-structured. There is the link, whatever is there, right? If you see there, web clickstream data that may contain some inconsistency in data value and formats. That is called as quasi-structured. Then if you go to semi-structured, it is your XML or HTML tags. There are tags. There is some structure to that. Right? That data has some structure. You have tags, you have your own links, HTTP references. Structured is your maybe XLS or database, and that is the tip of the pyramid. It is a very small unit. Okay? So this whole thing is what the data structures, different data structures are present. Okay? So hopefully with this introduction, at least if you get a rough idea of, okay, what are all the packages included in big data, that would be helpful, because this is what we will be carrying forward. Going ahead, we will talk about different data structures, how it is, and what to use to analyze these kinds of data. This is what we'll be talking about. Okay? So the next slide. Okay, why? Why is big data making such a big noise? That is what everyone will be thinking about. Big data, you're hearing it everywhere from, say, past 2 to 3 years. Until that, no one heard about big data. Why is it making such a big difference now? So if you say, these are the business drivers, okay? This is where we have heard from lot many customers or lot many people saying, this is what I need. And big data plays a role here. Okay. See, these are the 4 things that we came up with a little bit so that it gives a complete end-to-end picture. So if you see, the driver is desire to optimize business operations. And examples you can see: sales, pricing, profitability, efficiency. I have like a couple of examples for that. We will go in detail about that particular thing. Next is to desire to identify business risk, customer churn, fraud, default. So, for example, a bank. Okay, they have a huge data set, say maybe SBI or any other bank, right? They have 500,000 of users of data. So now, what the data they can make use of is what will be used here: customer churn, fraud, default. Using that data, they can come up with saying, if I give to this particular user base, set of users, will I get the money back? That kind of analytics can be done. And today, if I give, at 6 months down the line, what is the return that I can look at? That kind of analytics can be done. Okay? Then if you see, predict new business opportunities. Even now, as we are speaking, like maybe a couple of you are already come up with few ideas how big data can be used. In your own day-to-day life, you will come up with new ideas. So if you see upsell, cross-sell, best new customer prospects, you can just think over 100 ideas. We are in like more than 1 billion people here, and you can just see how much of data we are producing in India in a, say, not even a minute, in a day if you calculate. How much of data is produced? How can that be used? Whatever the Aadhaar card and all those things are coming up, right? You can just think about those many details are there. Every individual's data is there. So how can we make use of that for a new business? Okay? And then if you see, comply with laws or regulatory requirements. So this is a very good example again. Someone was talking about this a couple of days back. Say we have some one bank which is based out of one particular locality for now. Okay? They want to expand. They want to move into other countries. There are different laws, regulatory laws there. There are different, whatever the baselines, guidelines for them there. So at that point of time, with that data, whatever they're doing here, how do they map? How do they go about like expanding into their new areas? All these can fit into the final one, comply with laws or regulatory requirements. So these are the main business drivers, what is causing this big data analytics such a huge turn now. Okay? Every company is investing in like big data analytics. So why is that? This is like a small example. We can come up with many more such things. In the next slide, there is a difference between, you would have heard about data mining or even business intelligence. These are all the things that are already existing, right? So where does data science fit? So this is a very interesting topic because there are two very, very important axes here. X-axis is time and the business value is at the y-axis. If you see the low business value and past, this is taken care by business intelligence. So if you want me to just tell what is this, so business intelligence plays a major role in for structured data, traditional sources. Okay, it is not unstructured data. So the business value is also a bit low. And if you see the common questions what can be answered through business intelligence, those are, what happened last quarter? Why did we have, say, some 5% loss? That can be answered through business intelligence. Or where is the problem? In what situations did this problem occur? This is, these answers can be got through business intelligence. But if you go to data science, you see that the typical techniques, we'll come to the techniques later, but common questions, what if? What if I had, instead of 5-member team, we had a 10-member team? What would the impact be? Or it can even be telling us what will happen next. What if these trends continue? Say the rupee is falling now for say some 10 days. So what will happen, say another 15 days down the line? These trends can be based, these trends can be analyzed on whatever is already there. That is why data science plays a totally different role. And that is why we say data science falls in the category of future as well as at the high business value. So this slide is mainly to make sure that people don't confuse it with already what is existing, say data mining or analytics, whatever is already there, okay? So big data science is totally different. It's not what already there existing. No, that is not what it is. Okay, so criteria. So this is one more interesting topic. We had a long discussion. Actually, one of my senior person, she had to accompany me. She could not come down due to some personal reason. So we had a long discussion whether this should be there or not. Because I am presenting today, I kept the slide. I hope if she was there, she would have removed this slide. Because this is a bit confusing, at least for people who are coming to the big data field first time, this might be a bit confusing. But I felt this is a very important one. I'll tell you why. If you see the left column, how are the big data projects selected? What is the criteria for selecting a big data? This slide explains that. 3 points: speed of decision making, throughput, analysis, flexibility. I will go through this in one more slide, in bit more detail, but this is just for understanding, okay? So there are many projects, right? So on what criteria big data projects can be selected? These are the 3 criteria. And if you come to the right side, what is the architecture? You see the sandbox there. So now the present trend in the industry is you have a big enterprise data warehouse, right? Wherein all the data is fed. There is an administrator for that. He gives you the restricted access to that, and you'll only have to use it in the format and give it, put it back in the same format. This is the general architecture that we have in the enterprise level data warehouse. So now if you see, this is a total different ball game here. What happens here is, the person takes the data from different data sources, puts it in his sandbox, okay? And he can use the sandbox, mold it into whatever he needs. It is the raw data. It is not that what the administrator is giving you a restricted data, only this much you can use. These columns are restricted for you. Nothing like that. He gives you the entire data. You make the use of it. You come up with new analysis, new way of what can the outcomes that can be projected out of that. All those are your responsibility. And if you see the last sentence, that clearly says that it is analyst owned rather than the DBA owned. It is not database administrator owned data. It is the analyst. If you are the analyst, you have the complete control over the data. Okay? So this is a very generic way of putting it. We will go into a bit more detail on both these slides. Both these items in the next slides. But before going that, what I thought was it would be a very good one if I can share the use case with you. So this is one of the use case scenario that we came up with. I'll just add a couple of things along with this. If you see the situation, opportunity to create social media space for professionals. So LinkedIn, that was what was created, and how it is being used, it is like gone out of bounds now. Okay, so I'll tell you that, but before that, use of big data, you can see that 100 million users, adding 1 million new users per week. This is almost, I think, some 6 months old data, but this is still a trending one. And key outcomes are these things. I don't want to go about that, but now what I wanted to say was using this, right, online services. I at least personally know 3 to 4 companies that have come up using this data, plus what are your contribution to, say, the coding community, open source community, and what is your different social media status, whom are your close friends, all those things they are putting it together and providing it to the people who are looking out for candidates. Okay, so there is one website, NAC, okay, NAC it or just NAC, I don't remember. So that website, if you check, that person who has started it, he has an algorithm, and he goes through the various data sets, data source. It's a big data algorithm that he has put together. Okay, now you will be interested to listen to this. He has requested Amazon to hire a guy who is actually a 10th dropout. Okay, because according to his algorithm, according to his calculations, he's among the top technical guys what Amazon was looking at. So you can read the whole story there. The whole gist will be lost if I tell you through my words. You'll have to read it there. But what I would suggest is, I wanted to tell here is, this is the kind of services that we are entering now. Okay, they're going through all the data that is available and pick the information and give it to the people who are looking at it, looking for that particular information. So you can have a look at that. That's just an amazing story there. So such similar kinds of things, there are a couple of more sites that have come up, at least I have looked at personally. And I don't know how many of you seen in-maps. LinkedIn has a feature called in-maps that is recently, I think, around 1.5 years back built. So it gives a map of you, keeping you as a center of the position. It tells if you have, say, some 200 connections in LinkedIn, how can those be grouped? Those connections grouped, okay? If most of them are your college friends, it puts them together in a separate color group. If they are your fellow colleagues, they put them in a different group. And it is they're still improving on it. I heard it was stopped due to some reason around 6 months back, but they're still having plans to work on that. Okay, so in-maps will give you a very good idea about how is your complete connections in the LinkedIn. So this is one online service related example that I wanted to give so that you can correlate with what we are discussing so far. See, the photos, as I told, or the images or the videos that you have uploaded through your account can be linked to you, and people who want to, say, employ a person can go through this data and then come up with an analysis of their own. Okay, this is the kind of trend that is happening. Soon it will be much more evaluated kind of thing, and then they'll come up with better algorithms and better way of making it. So this is the example that I wanted to share. Okay, so now what they want to do. Who are they here? I have put 6 different categories, if you see. We'll go through employees, recruit sponsors, and become an advocate. So what is an advocate? It is majorly, like, say, in which field they are working on. They want to become the advocate of that particular field. Say, I'm a person who is working in, say, database related stuff. So I want to become a database advocate. I want to recruit the sponsors who can give a sponsor to me, fund me, and I want to work only in that niche area. If you go to the digital nomads who are like completely into what is happening, tech savvy folks, if you see there, to be the first human sensor and crowdsource knowledge, everyone wants to be the first person who will tweet, who will post, right? And then they'll say, I had tweeted this and 400 people retweeted this, or 600 people shared this. So that is what is there. Technology professionals, if you see, they want to know about the technology and which enables this big data analytics. So through big data, each expectation, there are different categories of people, what they want to do. That is what we are trying to say here. Okay, who is a data scientist? I have it next slide, so we'll park it there. Students, they want to see how data is impacting mankind and be a data scientist for at least one day and see how is it actually impacting them. And if you see the influencers, they want to share the experience, their network, and they want to participate in it. So maybe we all fall under the influencers category because we're all sitting here today. So, okay, now the data scientist part, we will have a next slide, but just to give a gist about it, they want to explore new diverse data to improve human knowledge. So this is what we're all looking at now. So we have huge data. How can we get some knowledge out of it? New knowledge that was not existing before. That is what data scientists are looking at. Okay, so as I told, the next slide, who is a data scientist? Okay, so, okay, a big paragraph about that. I won't go to the whole paragraph. I just want you to see the major key things that I will mention. Mathematics, statistics, data engineering, pattern recognition, and learning, advanced computing, visualization, uncertainty modeling, data warehousing, and high performance computing. Enough. Too much of words? Yeah. So, but this alone will not make a data scientist, okay? Data scientists are generally in a group, and each one of them will have expertise in this particular group, okay? If you have more than 2 or 3 fields of expertise, well and good. But generally, what happens is there will be a person who is a domain expert. Now, say suddenly someone comes up to me and says, okay, in healthcare, this is the problem. Okay, I'll go to that. Maybe I'll share the use case before. I don't remember which location in US, there was a shooting happened, accident in a school, and a small kid of 13 years was shot because of police could not reach at time, and they could not make sure that he reached the hospital at time. He could not get the medication. He was like, he died, okay? So there were lots of discussions going on. One of the doctor, he came up with a new idea, okay? He said, I will get the data of the schools that are located far from hospitals and police stations, where the police or the hospital will take more than 15 minutes time period to reach there, okay? So with this data, like to search this, he had to go through a lot of the city map, and he had to go through the different addresses of different hospitals, schools, and different databases, everything, different kinds of structure. At the end of the day, he got that data, and using that, now there is a system in each of the schools which says how much far the police station or the hospital is there from that school, and if there is an emergency, which is the best route, so that they'll not even take the 15 minutes. Okay, so now if you had asked me about this, I'm not the domain expert of healthcare, so I'll not be able to talk about that. But if maybe a problem comes up to me, and at the end of the day, I'm a good person at, say, advanced computing and visualization, I can tell you that this data looks like this, and it makes a very good impact, then yeah, I'm qualified for calling to be a data scientist. Okay, there's a huge market going for this, and if you see, there is like the trend that the data scientist or whatever the different names the people call it, there are literally very limited amount of resources, people who are actually ready to be in this field. Okay, so there is lot of investment going on to make sure that people are trained in these skills, who can like come up with totally disruptive ideas. So if you see the next slide, I'm going to tell you what are the different requirements. You have to be quantitative, technical, skeptical, communicative and collaborative, curious and creative. So this is not a big deal if you see that there, apart from technical. So technical points I discussed previously, right? The visualization aspect, advanced computing and all those. If you remove that part, if you see here, why all these are very important. Curious and creative, that is what makes each and every profile unique. You have to be creative, you have to be unique, come up with some kinds of solutions, right? That is required. Communicative and collaborative, why? You have a data, you have some kind of analysis made out of that. But maybe that is not a complete solution that you are looking at. There is a person next to you who is working on a different domain, but you feel if these two things are put together, that will make a more meaningful solution. It will give you the complete solution that you are looking at. You'll have to be communicative and collaborative with that folk. Only then it will be a complete one. That is why that is an important trait. Skeptical. Why is this important, you know? Because most of us think at the end of this project, I'll get this, and a successful project. No. Big data analytics is not about that. You have to be skeptical because initially only you should be able to correlate and tell, boss, this is not going to work. No. You have to tell that. That is why the skeptical is an important attribute. Okay? So this is about the data scientist. Maybe a bit deep into big data will start looking good. Okay, so here we are entering the ecosystem. I'm almost half an hour, so another 10-15 minutes. Data devices, all the different devices, they all form the data providers to us. Okay, and the second one, if you see, the second one in the white and blue circles, they are all the data collectors. Internet, government, medical, phone or TV, retail. You don't know, in the retail service, the big data is playing a huge role now. We'll come to that, but then data aggregators, they consume this data, put it in various formats, okay? So websites, catalogs, media archives, analytics services, advertising, okay? Then if you see who are the consumers, media, banks, employers, marketers, private investigators or lawyers, okay? So these four categories put together a big data ecosystem. Okay, so what big data ecosystem does and how that can be put into actual practice, we'll know by the life cycle. So every big data project, it has these 6 phases: discovery, data preparation, model planning, model building. You should communicate the results, operationalize, and then go back to discovery. Time's up. I started at 10. It started at 10. Okay? Okay, sure, no problem. So, okay, we'll try to wrap it up as soon as possible. Maybe we can talk it outside, because he said we cannot change the schedule. We'll go fastly a bit. So the next slide is, okay, I'll skip through that. That is not an important one. This is one of the major things that I wanted to discuss today. If you see, what is the kinds of problem that we want to solve? I want to group the items by similarity. I want to find some structure. What is the category of technique that we apply is clustering. Okay? Group the items together. Cluster them. If you want to discover a relationship, if a person is buying a cap, what is the probability that he will also buy a shoe? We'll apply that by association rules. Okay? I want to determine the relationship between outcome and input variables. Say there are 3 input variables, I, J, K, and the output is X. So will X change if I change I by 5 more points or decrease J by 5 more points? That will come to know by regression. So these techniques, I'm just trying to give you an overview here. You'll have to go through each of these techniques in detail. This is a huge mathematics involved here. Each and every problem to solve requires different techniques, okay? And combination of techniques as well. I want to assign some labels to the objects. You can do by classification. Time series. This happened at this time. you have a big data of, say, some 100 days. What exactly happened for 5 minutes at some particular location? You can do that. And text analysis is what all you know. Say we have some 500 tweets coming up here. Which all tweets spoke about big data session today? I want to do a text analysis on that. I had a couple of slides talking about how text analysis is done. I'll skip through that. Okay, this is a bit completely into technical. Maybe it'll go most of you above the head. But what I'm thinking is just to tell you what is MapReduce. There are two things involved. MapReduce has map, that is different procedures that it maps to that different procedures that are done. Reduce. So these two combined together is called as MapReduce and HDFS. So what is HDFS is where Hadoop comes into play. Okay, Hadoop is the thing that is happening right now. So Hadoop, HDFS are all completely interlinked. This is where you can see the image here. As I said, it has a map job, it has a reduce job. So these two things are put to the job tracker, and each of them are divided into different tasks. Okay, this is where Hadoop plays a major role. So you'll have to know, you'll have to dig deep into Hadoop to know an exact architecture of that. And then this is almost the last slide that I had. Different enterprise visualization softwares. So it is a important one. If you see, there are big names. Whatever the visualization you will have, it will be at its best. You will not even be able to imagine what kind of visualization effects they will provide. Okay, so yeah, that is what I had. So in detail, if maybe a bit about a couple of slides that I ran through, if anyone wants to discuss, we can discuss it offline, maybe near the cafeteria as it was mentioned earlier. I am fine with that. So thank you all for bearing with me. And if you had any questions, feel free to come over. Satish, myself, I'll be waiting outside because there's another session going. Will be starting right now here. So thank you again. Thanks a lot.